Hey everyone, welcome to another Dapr University workshop. Today we're going to look at the Dapr 101 workshop where we're going to talk about installing the Dapr CLI, setting up locally, using the state management API, doing some service invocation, and also the pub sub API. So I'm Mark Duiker, I'm developer advocate at Digrid, and Digrid is also hosting all of the Dapr University lessons, as you can see here. So first I want to highlight what courses are out there. So if you go to Dapr University online on digrid.io, there are like 3 courses now. There's a Dapr 101 and we'll be running this today. Then there's a course about Dapr workflow, so using Drupal execution to build reliable distributed and long-running systems. And we also have Dapr agents, build LLM-powered intelligent applications with tools and workflows. There will be more lessons, so very soon there will be also a .NET Aspire in Dapr lesson as well. There will be like a Dapr running in production lesson, and there will also be like a Dapr and Spring Boot lesson as well. So over time there will be more and more lessons that you can try, and it's completely for free. How this works is we have like an online cloud environment. That's our development environment, and we are going to use that to run our Dapr application. So we don't have to install anything locally. We don't have to clone any Git repos locally. Everything is managed in this cloud environment, which is pretty useful. If for some reason this environment does not work, maybe it could be like VPN related or network related, you can fall back to the actual underlying source that we're using, and that are the Dapr quick starts. So this is also a GitHub repo in the Dapr org, and we're using the Dapr quick starts actually, and we're using the source code, using all of the applications there. But you can see it like a fallback solution in case the environment does not work for you. But it's also linked in the lesson itself. If you complete it with these challenges, which are not very much, there's a lot more information in that quick starts repo. So you can do all kinds of demos and tests for many days to come. So this challenge that we're doing now, the track we're doing now contains of 5 challenges, and it should probably take like 40-ish minutes to complete them all. So 5 individual challenges about the topics I mentioned before. If you do not use this environment for more than 10 minutes, it will time out. So your session is gone and you have to restart the track, which is fine. You can start this track up to 5 times. But just be mindful that if you go for like a coffee or something and you're away for more than 10 minutes, you have to restart the environment, and your progress will then be lost. But the track is not really building on top of each other. You can actually, if you see this progress tab here, you can actually move on to any other lesson. So if you maybe stopped at using the state managed API and your progress is lost, you can restart the track and then just immediately go here and start it right there. So now we see this blinking green button means that our cloud environment is ready. So I'm going to click that so we can start it. And by the way, if you complete all these 5 challenges, you can claim this digital badge. This is hosted on a platform called Holopin, and you need like a GitHub account to claim it. Okay, so yeah, you're probably here because you're like super new to Dapr, right? So that's why you've joined this. So let me first explain what Dapr is and why people are using it. So Dapr, the distributed application runtime, is used by many large enterprises like Grafana, Zeiss, FICO to speed up distributed application development. So, and we do like a survey every year amongst Dapr developers, and on average, they claim to save like 30% of development time when they use Dapr compared to when not using Dapr when they're building backend applications. So that's like a quite significant reduction in time, which is really cool. So Dapr provides APIs which decouples your application code from the underlying infrastructure that your applications are using, such as like state stores, message brokers, secret stores, and much more. So this means that your code does not contain any resource-specific code or dependencies, which in turn allows you to actually swap out these underlying infrastructure resources without any code changes, right? So we can swap out one message broker, maybe Azure Service Bus, with another one like Kafka, for instance, without any code changes. So that also makes it very powerful. Not only if you want to swap out these message broker systems, because that's something or hopefully that's not something that you'll do like every day, but it's also very useful when you do like local development using some local components, and then you move to a test environment or to production environment using production components without any code changes. All right, so you can develop with Dapr in almost every language there. So as this diagram here shows, you write your application here, this green hexagon, in whatever language is out there. We have some client SDKs for Dapr to make it a bit easier to do it. But for a lot of things, you can just communicate to the Dapr sidecar over HTTP, because that's one important aspect of Dapr. Dapr is not part of your application, so it's not in the same process, but it runs in a separate process next to your application. So that's known as the sidecar pattern. And Dapr applications are typically used in like a Kubernetes setup. So Dapr offers like a lot of different APIs, right? So this section here is everything that Dapr offers. All of these lighter squares are all of the APIs that's part of Dapr. And again, Dapr is also evolving year over year. So also the number of APIs is also growing year over year. In this track, we'll be using state management, service invocation, and publish subscribe. And so we are only covering 3 of the APIs of the like 11 now in total. Oh no, 13 even. But there's much more. So one of the other tracks is like workflow, and the other track is Dapr agents, which is not even on this list. Dapr also comes with like built-in observability, security, and resiliency. We're not touching on those specifically in this one-on-one track, but that's also included because all of the communication goes through this Dapr sidecar, which means you can very easily apply resiliency and observability and security. Because all of your traffic is going through this sidecar, so it's very easy to measure. And yeah, since Dapr is like language agnostic but also cloud agnostic, it's typically run on Kubernetes, but you can also run it on just the VMs, right? Because they are also running it now, or not yet now, but in the next challenge, we'll be just running it in a cloud VM. So most of the people use Kubernetes or some form of Kubernetes. In Azure, there's also, for instance, Azure Container Apps. Via Digrid, we have a service called Catalyst, which is sort of like a serverless Dapr. So if you're interested in running Dapr not on Kubernetes, and there are definitely options for you. So either VMs or use the Catalyst service. Right. I already mentioned that we have like a couple of language SDKs. So I'll be doing the demos in .NET, but you can also use this track with Java or Python or JavaScript. So those are the 4 supported languages that we have in this track at the moment. Okay, I'll not go over all of the Dapr features and APIs that we have, but yeah, you should really see Dapr as like your developer tool belt, right? So Dapr offers a lot of features, but you're not forced to use all of them, right? So maybe you just start with one API, maybe you just start with PubSub and see how that goes, and do like a proof of concept. And once that goes well, okay, maybe you extend your use of Dapr further. So you don't have to go all in with Dapr. You can just very easily start small with just a couple of services, just 1 or 2 APIs, and then gradually build that out. Okay, so that's the theory. So now let's move into the next one, and that will be about installing Dapr locally. So if you've never done that, we're going to install Dapr in this cloud environment now. All right, so the Dapr CLI is used during local development, and we're going to do you're using it when you run your applications, for instance, and there's a very nice thing called Dapr multi-app run. So if you want to run all of your applications at the same time, because Dapr is typically used for backend development and microservice development, so it's very likely that you want to have some multiple services up and running, you can use the Dapr CLI to do that locally. So let's first download this, and there are a couple of ways how you can do that. So this is a Linux-based machine. If you look at the Dapr docs, there's also different ways to download or install the CLI. So we do like So to have the Dapr CLI, we just get it from GitHub in this case. You can either copy this and paste it here in the terminal environment, but you can also just click run, and that will actually copy and run it immediately. So we'll see now that the Dapr CLI is being downloaded. So it's downloaded on this cloud VM now. We can also see the version of the CLI. It's 1.15.2. And by the way, Dapr 1.16 is coming out very soon in a couple of weeks. So this will also be updated. So we can verify this installation of the CLI. So let's do a Dapr-H. I'm going to run this now. And we see some output here, some nice ASCII art, and then all of the how you can use it, all of the available commands here. So we're not going to use very much of those. We are only going to use the init command, and we're going to use the Dapr run command in this track. So let's first initialize, because what we have now is we have the CLI locally, but when we run applications, we need to have a Dapr process next to our applications. So, and that's not available yet because we need to download that Dapr binary. So when we going to run Dapr init now, so that this will fetch and install the Dapr sidecar binary locally. It will also create like a development environment, like a profile with some default Dapr configuration for us. So next to that, it will also download a Redis container, because Redis is used as the default message broker and also as the default key value store. It will also install a Zipkin container for default observability. It will create like a components folder in your profile, and I'll come back to components later, but you can use components to actually define what the underlying infrastructure resources are. It will also download and run two Dapr-related services. So one is called the Dapr placement service. This is really specific if you're going to do actor development with Dapr, which is a bit more an advanced topic. Hopefully we'll get another Dapr University track for how to use actors, but it's definitely not part of this track now. And there's also the Dapr scheduler service, which is useful, or actually which is required when you want to do like job scheduling or Dapr workflow. But again, that's not part of this track. Okay, so let's run Dapr init to make sure that we can have all those containers running locally and have the Dapr binary as well. Well, it's already failing. Okay, let's try this again. I'm not sure why. Ooh, we've reached the limit at Docker. Oh, okay, that is unfortunate. So I'm not sure when this limit will be reset. Let me have a quick look, because we're making like unauthenticated request now. 100. Let me see if. Okay, well, maybe I do have to run this locally now. Yeah, I think I will continue and run this locally because I cannot easily increase this. I'm not sure when this will reset either, and maybe you're running in the same issue as well now. Let's try it again. No, okay. I will change, and I will go to the quick starts that I have checked out earlier. So what I'm doing now is I'm actually going back to the quick starts repo. So I already put it in the chat, I think, right? Yes. So we're going to the Dapr quick starts repo. You need to clone this, or well, I suggest you clone this repo locally, which I already have. Open it in your editor. In this case, I'm using VS Code, and we'll explore a bit from here. Okay, let me actually increase this a bit. All right. So the first thing what we're going to do now is I'm going to look into state management. So in this case, I am looking into some C# examples here, and I'm going to look into HTTP, because you can use the Dapr APIs with different in different ways. You can either make direct HTTP calls from your application to the Dapr sidecar, to the Dapr process, or you can use an SDK in your application. But you're not required to use this SDK unless you do things like workflow, because then you need to write a workflow in a language. But if you use the other APIs like state management, service verification, PubSub, the use of the SDK is optional. It's usually a bit more developer friendly to use it, but if you don't want to include these dependencies, you don't need to. Okay, so I'm going to read off this all these readmes a bit instead of following the instructions of instruct. So what we have here is we have an order processor service. In this case, I'm using C#, so I have like a CS project file and I have a program CS file. And let's have a look what that program is doing. All right, so what the program is doing is it's first we create a base URL, and if it's not set in an environment variable, it uses the local host one. We get a port number, and that's also the default of 3500, and we have what is named here a Dapr state store. So this is the name of the Dapr state store component, and I'll come back exactly what that means. And since we're not using a Dapr SDK, and we also don't see any dependencies of the Dapr SDK here, but we see here that we're using an HTTP client. We are setting a new header on that client to make sure that we set the type to application JSON. Then we do like a for loop from 1 to 100. We create like an order, which is like a very basic record type. We serialize this order, and then we make sure that we create a key and a value. And the key is then the order ID as a string, and that the value is then the order record itself. So what's important to realize is that the state management API of Dapr is that's not a SQL state API, but it's like a key value store API. All right, then we create like a new string content. So we do this for the, so this is the content that we're going to use for our HTTP request. And then we use the HTTP client to do a post to this base URL. And then we use the state endpoint. So this is like a generally available state endpoint. So it's not in alpha or beta, it's version 1. The state endpoint, we include the name of the component, which was like a state store in this case, and we provided the string content here. And we are awaiting it. So this will actually write some state. So how we actually then get some state is we use the same HTTP client, and we do a get string async. And the URL is almost the same. So it's again state and state store. But since we are retrieving a key value pair now, we provide the key. So we are actually providing the key of the order, which is the order ID. So this is what you have to use to get back your key value pair. So there's also a delete operation as well, delete async. And in that case, you make a delete HTTP verb, which again is the same syntax as the get. And you're deleting, and you do that by providing a key of the key value pair. All right, so I will actually comment this out because then we can also inspect the state later. Because if you run this in a loop, it will first save it, we will retrieve it, and then we immediately delete it. But I want to look at the state later as well. So I'm going to comment this out, and then I will run this. Let me open up here. Okay, so now I'm in the HTTP folder of the state management C# HTTP. Right, so here I see my order processor. I also see a dapr.yaml file and a makefile and a readme, but I will show you the dapr.yaml file because that is what I will use now to actually run the application. So if I click on this dapr.yaml file, so this is a a Dapr multi-app run file, which actually instructs the Dapr CLI and what are the location of the resources that we are using. In this case, we are using some state store resources, and what are my applications. And so this like can be like an array of many different applications, but in this case, it's only one application that I'm running. All Dapr applications require an application ID for unique identification, and this ID is also used in some different places, as I'll show you a bit later. You point to the path where the application is. In this case, it's on our order processor, and you provide the command how to run it. And since this is a .NET application, we're using .NET run, and we provide this path. So, and this all will be run using the Dapr CLI. All right. I think we have this. All right. So what I'm going to do now is I'm going to do Dapr run -f dot. So I'm going to use a Dapr run command, and by doing -f, I'm instructing the Dapr CLI to use a file, and by just providing a dot, the Dapr CLI expects now a dapr.yaml file in the same location as I'm running this command. So let's do this, and this will now first build our .NET solutions. And well, it's only one, the .NET project, and then it's actually executed. As you can see, it is already executing it. We see like saving order, getting order, etc., etc. And this will just continue until it reaches 100. So let's stop it because we don't need to see all that. What I do want to show you is where this is now actually stored, right? Because our application, if I go back here, in our application, we are just making some HTTP request. We mention the Dapr state store with just a name, state store. But I know that under the hood, it's using Redis at the moment. So that is configured somewhere. So let's have a look where it is. If we collapse this a bit, there's a folder here called resources. And that was also pointed here in our resources path. So when we run Dapr run -f dot, we instructed it to look for a resources path like 2 levels up in resources. So that is this one, and this one contains like 2 YAML files, and these are the YAML files that also got loaded into the process. And one of them is named state store. So let's open that up, and this is the component file. This is a Dapr component file, which Dapr is using to actually know what is the underlying resource that Dapr is using. So in this case, we are using state.redis. So we are using the Redis container that we just installed when we installed Redis. Or actually, that part didn't work yet because of the rate limiting. But when you run Dapr init, it will download the Redis container. So that's what's being used, and then there's some metadata that is usually specific for Redis. But we see this name here, so this is the name of the component, and this is the same as the label in our source code. So the name of the component is state store, so this matches the Dapr state store name. So this label can be anything you want, but this is the only thing that appears in your application code. All right, so Redis is used on the hood. So now let's have a look at the storage now. So I've got like a visualizer in VS Code to let me look at some Redis state. So these are all of the keys that the application order processor just stored. And all of the order IDs were just were an integer, right? So there was 1, 2, etc. But we see that the key actually has a prefix named order processor, and order processor, that is the name, that's the application ID of our application, right? So if we go back to the dapr.yaml file, so we see that the app ID is order processor. So by default, when you use the state management API and state is and key value pairs are being stored in a state store, it uses the app ID as a prefix for your keys. So this is a certain strategy that Dapr is using by default. It always prefixes your state keys with your application ID. You can override this strategy by either providing it as some other value or getting rid of that value. But this means that by default, state is only accessible with the servers that actually stored it as well, right? So if you want a different behavior, you can override this behavior and choose a different state prefix strategy. So if I click on one of these things now, we see like there's like two fields. There's a data field, and that contains the actual data. In this case, it's a very simple object, order ID with just one, and there's a version as well. So what happens if you store the same data again using the same key, then this, of course, the data will be updated. But in case if I run the same program again, the data field is the same, but this version will then increase. So each time you save some state using the same key, this version will be incremented. All right. Then I'll move on to the service invocation, which is also the second lesson in the instructor environment if you're there. Again, I'll be choosing for the C# one. So in case of service invocation, so service invocation, just very shortly explaining what it is. So that's like synchronously communicating between two services, right? So you do this via HTTP. So you make a request and you send it off to another service, and that other service then gives back a response to that service. So in this case, we have two services here. I'm again using C# because I'm most familiar with that. So we have two services. There was still one question about the state. The prefix is default behavior and mandatory always. So this application ID prefix is the default behavior, but it is not mandatory. Yeah? So you can choose to remove the prefix altogether. Yeah. And that you can find it in the Dapr docs as well. Yeah. So we have two services here. We have a checkout service and we have an order processor service. So let's first have a look at the program service. So this is the servers that will create the request and send it to the order processor service. So now we are actually using the Dapr SDK. So we have a dependency on the Dapr client here. And we're using the Dapr client to create us a special instance of an HTTP client. And so it is a regular .NET HTTP client, but we are actually setting a special HTTP header that Dapr will use. So we use this create invoke HTTP client method, and we apply where we provide the application ID of the service that you want to communicate with. So, and that has an app ID of order processor. So if you then use this HTTP client, this header, this app ID header will always be set. So Dapr then knows that the target is always this order processor, and Dapr will then figure out internally what is the address of this app ID. So you don't have to worry about any addresses. You only have to worry about the application ID that you want to talk to. So now we do a for loop 20 times. Again, we create a basic order record. We create like a cancellation token. And here we are invoking the service. We use the HTTP client and we make a post, and we make a post to a orders endpoint. So this orders endpoint has to exist on the order processor service. We provide the payload and the cancellation token. And we just do a console write line, and we wait 1 second before we continue. Now let's have a look at the order processor service itself, which is receiving this request. So that's here. So this is a web service, right? So the other application, the checkout one, is like a console application. It's just like making requests, so it doesn't need to be a service. But this one, it needs to be up and running all the time. This is a web service. So this is a minimal web API example. And here we have configured a post endpoint of orders that's accepting an order type. And we simply do like a console write line that it has been received, and give back a 200 OK, just serializing this order again. So no rocket science going on here. So let's run this. And again, I need to make sure that I am in the right folder. All right. And now if you look at the dapr.yaml file, so that's the multi-app run file that I'll be using now. Now you see that we have two applications that I'll be running. So it's the order processor, which is the web service that needs to be up and running. And we have this command line application checkout. Also note there are no resources now, right? Because we are not depending on any resources yet. So there's no state store that we're using. Servicification doesn't rely on any components like some of the other APIs do. All right. So let me run this now. So again, Dapr run -f and dot to instruct it to start both these services. So this should start both the checkout application and the order process. And the checkout application is then going to make this request. And yeah, we see here that it's happening, right? So first we see the order processor confirming that it received the order, and then the request is being sent back to the checkout service, and then we see the checkout service responding as well. I think it was just 20, so let's wait until it has the 20. All right, so that worked. And so the nice thing of servicification with Dapr is you don't need to know the addresses. You only need to know the application ID of the service that you want to communicate with. All right. So I think we can move on to the pops up one. All right. So pops up communication is like asynchronous communication, right? So in this case, we are needing a component because we are using a message broker under the hood. But the nice thing is that in our application code, we will only be using the Dapr PubSub API. In this case, I'm going to use the SDK version, so we're not going to make HTTP calls, but we're using the Dapr SDK. But the application only depends on the Dapr SDK for this. So we're still using Redis under the hood in this example, but there won't be any Redis specific code in our application. And so also, this means we can easily switch to another one like Kafka or RabbitMQ or Azure Service Bus. So we can do that by simply switching out different of these component files. And so so this is the only thing that we are referring to our code. I will show the code in a minute. Order PubSub, so that's the name of the component. And this is of type PubSub.Redis. And so we'll be using the same Redis container as our state store, but that also has like Redis streams. So Redis streams is the underlying message broker that we'll be using there. So in this example, we have this, a very similar setup as before. We have a checkout service and or I think this is like a command line application. And so this is a checkout application, and that's actually publish a message to an order processor service. So we do have a dependency on the Dapr client now, on the Dapr SDK. We are going to loop over it 10 times. We create an order, and now we use the Dapr client builder to build us a Dapr client. And we use the publish event async method on the Dapr client to publish an event to the message broker. You then have to provide some information about what the name is of the component. So this is the component name that we saw in the PubSub YAML file. You have to mention the topic. So when you do like local development, you don't have to create the topic like in advance, but if you're running in production, you have to make sure that the topic is already set up and provisioned in advance. But if you're just doing this here on your local device, you don't have to set up an orders topic first. That'll be handled. So the component name, the topic name, and then there's the payload that you're providing. So we do a console write line there that we publish the data. So let's have a look at the receiving end, which is then subscribed to this topic. So that's the order processor. So if you look at the code for this one, so this is a web service. Again, say the same example as last time. So this will be up and running. There are a couple of methods that you have to use in your application builder, because what Dapr does by default is it will wrap all of your messages in a cloud event envelope. So cloud event is like an open standard It's been, I think all of the major message brokers use cloud events as well. And Dapr used it to enable distributed tracing. Because cloud events, except for the payload, there are some additional fields in the cloud event for like trace ID and parent trace ID and so on. So cloud events are like very useful, and depending on the language, you have to instruct the application to actually use cloud events on the receiving end. In this case, since we're using C#, we also have to use the map subscribe handler extension method as well. And what this enables is we can now decorate our posts. And so this post method will actually be handling our incoming messages on this endpoint. But we can now use a topic attribute. And here we specify the name of the PubSub component, which should be the same component as the other service is using, and the topic that this is subscribed to. So if you don't do the map subscribe handler, then this topic attribute will not work out of the box. And then you first need to write a separate sort of receiver function, which then calls this handler function. But this is the cleanest way to do it in .NET. Even if we are using cloud events, but what happens here is that the application will unwrap the cloud event. So what we are receiving here is our order. So it's the same order that we were actually sending from the checkout application. And we simply do just a console write line and we give back our results. That's okay. So it's very important that you are always doing an okay or accept to actually acknowledge that you have received something. Okay, let's again need to make sure that I'm in the right folder. So open this in my terminal. Again, I have a look at the dapr.yaml file. So we are going to run two applications. The order processor and the checkout one, both the .NET applications, but we are also pointing to the components folder again, because we are using a component, because we're using a message broker, in this case, Redis streams. All right, so let's do dapr1 -f dot to run it, and then the checkout service will actually start by itself and actually publish all the messages. Yeah, here we go. Here we see both the log output of the checkout and the order process service. All right, so it's all up and running, and it's completed. I can show you indeed Redis streams as well, I think, but we don't see anything in there. So this is the orders topic that was created by Dapr, which is a stream, and that still has data in there. Because it's a stream. Dapr works with both message streaming components or providers, as well as queuing providers. So Dapr can handle both. All right, I've shown you all three APIs now that I wanted to see. And so if you're using the instruct environment, make sure to claim that university badge, so you can celebrate that you've done this. All right. Thank you very much, and I hope to see you in a couple of weeks for another Dapr workflow run. Thanks, everyone.